Hello, hey, this is John DIY on the FF Cars forum, and just want to say hey, thanks to everybody out there. Also, there's some friends out there and stuff that I've been talking about this car quite a bit, and I wanted to give everybody a chance to kind of take a look at what the GTM is and what some of the stuff I'm doing on the car looks like. GTM supercar, it's a factory 5 kit, and it's a pretty extensive kit, and it's quite complex for the average builder. It's based on a C5 Corvette chassis, and a lot of guys use the C5 to take parts off, suspension parts, and some of the things like gas tanks, rear view mirrors, wiring harnesses, and things like that. What I've done is I've done something a little different. I've gone with a 7-liter LS7 out of a Z06 Corvette. This engine was built by RPM Motorworks out of Southern California, and it's a 660 horse LS7, and it's got a cam with it's basically like a Lingenfelter build, 660 horsepower. That's actually not at the rear wheels, but I've not dynoed this car yet. I've just got it running. Some of the systems on the car, what I'm going to do is I'm going to walk through it and also show you some of the technical aspects of the car and what some of the details look like when you get into something like this. Basically, it starts out, we have a manual here. It's a pretty thick manual, and the manual really gives you some basic ideas for taking a C5 Corvette and taking the parts off of a C5 and building those parts into this car. And again, it's a suspension, things like the A-arms down here, upper and lower A-arms, rear view mirrors, gas tanks. The gas tanks are actually in here. There's one capped off with a Crown Royal bag. That's not actually a Corvette gas tank, but you can use the C5 Corvette gas tanks for the same thing. Anyway, the build entailed, it's got you get this manual. The kit is roughly $20,000. I think they've gone up to like 24 now, which is still a pretty good deal for a supercar. And with the kit, you get the interior, leather interior, and a bunch, nuts and bolts and a whole bunch of stuff. But you do not get the engine. You do not get the transaxle, and there's a lot of other options on the car that you can choose to build in yourself if you want to. What I've done is I've gone pretty extensive with upgrading this from the kit, so it's far from what the original kit was. The kit includes the chassis, which is welded, also all of the aluminum paneling and so forth that goes around the inside of the car, and the suspension components, not the A-arms, but the springs. These are Coney coilover springs in the front and the back. Here's what it looks up front. And by the way, I've got all this wiring and everything hooked up because I'll run into that stuff in a little while. Show you some of how we do the diagnostics and so forth. Anyway, when you get into a car like this, a lot of people ask on the forum, hey, what does it take to build a car like this? And they're not quite ready to get into it. But it's hard to really address those questions on the forum. And so what I want to do is I kind of want to walk through just basically what it takes. Basically, for a car like this, you have a manual, and that manual is by far not enough to get through this thing. There's going to be a million questions outside of the manual that you're going to get into. So what you want to do is you want to get yourself a folder and start dividing all that stuff up into different sections of the car, and go on the internet and download all the details of your wiring harnesses and various production pictures of the engine and body and stuff like that from a Corvette, so that you can have reference to those as you're building the car. And what I've done is I've separated these with tabs, talking about the cooling, clutch, air conditioning, fuel, and all the other systems in the car, so that when I need to go back and reference these things, I have those. In addition to that, I've developed a book specific for the wiring on the car, and there's never enough napkins to write wiring diagrams on. So a good idea is to get into the computer and use a program You know, you can use anything that draws lines. I use AutoCAD myself because I know how to use it. And what I do is, here's an example of the wiring for the cooling system that basically brings together relays and so forth that are connected to the engine computer. And I'm able to draw this out and kind of think about it and reference, a lot of the factory stuff, that comes out of these basic sheets and things like that I download from the internet. But anyway, it's hours and hours and hours of research, looking at all this stuff and then, bringing that together and drawing your own plan for the car and how you want to do it. It doesn't have to be as neat or as complicated as maybe what I've done, but basically you need to have some kind of a record of what you do so that down the road you can work on the car. So anyway, that's a big important thing. I'd highly recommend that anybody that gets into a car, in addition to the experience and mechanical aptitude, that they have the ability to get in there and actually take the time to document stuff and do the research they need to do. This car, I'm going to try and go through this fairly quick because I don't want to make a boring video. But anyway, what I've got here is this is a Factory 5 GTM. What I've done is I've put non-Corvette, what I've done is I've gone away from the C5 Corvette. I've used different wheels. These are custom BC forged two-piece alloy wheels that are made by a company in Taiwan. These you can actually customize these. I drew these up on a CAD program and double checked the back spacing and had these made in Taiwan, and it costs as much as a it was mid-range. You can pay a lot of money for custom wheels upwards towards $6,000 or $7,000. These were right at about $4,000, which is substantially less. They're nice wheels. Inside I've actually got Z06 Corvette Z06 brakes and rotors. These are competition grade brakes and rotors, and they provide, they're going to provide plenty of braking for this car. And not only that, they're production, and so I would expect them to last. Some of the aftermarket stuff that you get, it's not proven like some of the production stuff from GM. So I decided to play it safe and go with what was out there. And again, there's plenty of braking power for the car. Some of the additions I did with the LS7 package, again, it's a 660 horse version. The head's been ported, the intake has been ported. It's got a different cam with a pretty healthy lift. I think somewhere around 700 on the lift on the cam. Typically, the cams, I think in the LS7 are somewhere around 590 or something like that, 590, almost 600. This is quite a bit higher, and when you hear it crank up, you'll definitely hear it. I've done all the heat protection on the engine, all the wrap and so forth. This thing gets pretty warm, so I've got all the coolant lines all the way through the tunnel. You can see them down in there. That's all wrapped up to keep all that stuff as cool as I can keep it once all this stuff is covered up. Also, because of the proximity of everything on the engine compartment, it gets really hot in here. As you can see, this is all the fuel stuff here, and the headers are right down there, and all that is protected with heat sheaths, fiberglass, and various tapes and so forth to keep all that stuff as cool as I can keep it. Later on, I'll actually probably put some fans, and then there's some intake air and a cooling scoop up on the hood, or not on the hood, but on the roof of the vehicle. You can't really see it in the picture, but if you look up the Factory 5 GTM on the net, you can see the cooling that's provided from up on top of the car down into the engine compartment. In the back, these are Kooks headers. This is a crossover pipe that helps balance the flow, and it's a kind of a performance feature. It also looks nice, and all that is wrapped. I took the effort to wrap all this. I didn't want to ceramic coat it. It's just my own preference. But anyway, it's all wrapped up. Hopefully that'll stay pretty cool. Right over the top of the engine, you'll have a big piece of glass basically, and then the fiberglass from the car. So it kind of comes right down over the top from there, over the back. It's not much higher than than maybe, you know, where my hand is here, probably 8 inches above the exhaust. So your exhaust is going right through the fiberglass of the car. Underneath, this is a Mendiola SDR transmission or transaxle. And the drive shafts, you can see there's a boot next to the CV. Those are Lobro CV joints. There's the drive shaft coming through there. I think that's about 1.25 inches or so forward, maybe 1.5 inches drive shaft, solid steel. You can see all the bolts. I've put torque stripe on those to just verify torque kind of as I go along. And I do that a lot. The same thing on the transaxle. All the bolts on the transaxle, the bolts that actually bolt the CV joints in place, those are all torque striped as well. It just gives you an indication that you've gone over that area, so you don't have to come back and wonder if you tighten things down. This is an oil catch can. This is a dry sump engine, so the oil is actually contained in this tank down here. On this particular installation, I'm running it's about a 1.5 gallon tank, and then there's oil in the engine as well. And that's for cornering and things like that on a high performance engine. That helps pump oil to where it needs to be under load, and when you have accelerations when you're on the track. Anyway, this goes right down to the side of the block. Basically, there are lines that are down inside there. It's real tight. I had to actually build this whole mount in here. This is not stock on the GTM, but I had to fit that in there and build various brackets and spacers and things like that. And you can see down inside there kind of some of the areas that it ties in, and I had to make a little panel there at the bottom of the tank that comes out. There's a lot of things like this. This is a little gas tank bumper. It just kind of keeps the tank in position. And then up here on the top, I've got clamps that actually clamp and apply pressure to the tank. You can actually tighten those down, and it'll actually hold that tank down, keep it from bouncing around and so forth. You can see I use a lot of aluminum angle and aircraft rivets. There's a lot of aircraft hardware in the car in general. A lot of these are solid rivets there, and aircraft nuts and bolts and nut plates and things like that. And then down here, down inside, there's actually the engine computer is right there, and then underneath that, down underneath, that's a fuse box. The engine computer's under that, and then underneath the engine computer, way down in there, is a Race Logic traction control system, which provides traction control under acceleration. It runs signals from these white wires that go to each wheel, and that tells the computer, hey, your wheels are spinning. And then what the computer does is it interrupts the fuel flow in the ignition to the engine, and all that's something you can set, on the computer, which I'll show you in a little while. This is all the paneling, basically all the paneling on the inside of the cockpit. All this stuff is basically screwed in place. I put nutserts or inserts into the frame where I can use screws and actually remove these panels. The guys at the factory, they tell you to rivet this stuff on. Problem is, if you rivet it on, you'll never get to it again. And so I've decided to make all this stuff removable to include all the panels up inside. All this stuff, there's nut plates and screws instead of rivets for all the stuff that I need to get to later on. And I made access panels. I used cam locks, rivets, and a lot of stuff you can buy on aircraft spruce and some of the aircraft hardware companies that sell this stuff. It's not cheap, but it really makes a difference when you're trying to work on this thing down the road. This right here is part of the ISIS system. The electronic system in the car is basically computerized. It's not traditional like the typical fuse box arrangement in a car. What this does is it has a system consisting of a master cell, which is actually hidden under this box. It's a computer that takes switch inputs from all the switches in the car, whether relays or toggle switches, light switches, and that sort of thing. And what it does is it sends a signal to the power cells, and you'll see the blinking light there, and then there's a bright light up to the upper right. And near the bright light on the upper right, you'll see different colored fuses. These are lines of fuses for each one of the circuits that the master cell controls. So the master cell gets a signal input, it sends it to the power cell, and the power cell, you can see the larger wires coming out. There's the red wires, those are that's battery power. And then it takes the battery power and sends it through each one of these wires to the front of the car, to all the components like the lights and so forth. And it sends the power to those components. The nice thing about that system is that you don't have all that heavy duty wiring under the dash, and instead you keep it isolated to the front and back of the car. And it also gives you the ability to log onto the computer and actually troubleshoot all the systems. So right now I'm monitoring battery voltage, but when I want to, I can check the various switch inputs here, and I can go through and I can troubleshoot the car. Like if I want to turn headlights on, you'll watch the little blocks there, and I turn the headlights on, and then it should give me a signal. You see the little blocks light up, and then they'll go off again. And so I can double check all the electrical circuits on the car using that. And then the other thing here about the ISIS system is I can go to the I can go to the engine, and you'll see the ignition there. That's an ignition switch. I actually can turn it on and off. You can hear the fuel pump. That's the ignition turning on, and later on I'll show you how you actually start the car using the starter there. And then the lighting, this controls all the lighting, and this controls everything in the car. I have parking lights, high beams, and then I've got door poppers and heating and air conditioning controls. Here's the heating and air conditioning, which I'll have in this car, and there's the sliders. And basically, if you have an Android or an i5 or an iPhone, you can pull this stuff up on an iPhone, similar to what I actually have set up here, which is a Droid, and you can run ISIS through a Droid or any basic screen that accepts the Wi-Fi signal. So this is running on Wi-Fi. There's actually a Wi-Fi box that is laying around here over there, and that's the Wi-Fi. Basically that's a hardwired Wi-Fi web page in that box, and what that basically does is it provides this interface here. So it's just like a web page, and it's got all the various troubleshooting and circuit testing and all that kind of stuff. This is kind of where I'm at. I just wired up the column, and this is all set up for testing, making sure that everything is good to go before I button it up and complete the whole thing. You want to make sure everything on the car, the engine, is, you know, every little thing that you can possibly do to make sure it's working right. You want to do it before you start doing the body work on the car. Here's the aft master cell, or aft power cell, and these communicate with the front power cell and the front master cell. It's actually only one master cell and two power cells on this car, but anyway, the master cell communicates with this via this cable right here. This is called a CAN cable, and again, it's communicating in series. It's kind of chain linked with the front power cell from the master cell, and so all those signals from the master cell are assigned either the front or the back power cell, and anyway, it just figures out where they're at in the system, so it knows. And then you have assignments for each one of the circuits and so forth. So, and then all the wires, all the various wires have different colors, so it's not too bad as far as installing it. Went pretty easy, and it worked the first time, which is not typical of most electrical projects. The shifter in this thing, this is again for the Mendiola Transaxle. That's out of a Toyota. I think it was a Corolla shifter or something like that. But anyway, Factory 5, their typical, the piece they send you with the kit is a mechanical shift linkage, and when you get the Mendiola, you want to make sure and go with the cable linkage. The cable linkage provides a smoother shift action, and it's just it's better all the way around as far as the you know, you don't have the play and all that kind of stuff that you have in a typical linkage. The linkage through the you know, from here all the way back to the transaxle